Okay, as part of our team interview, I, Jeppe, the ground station commander at the SG Can Science team from Silkeborg Gymnasium, I have to walk you through one or two lines of code. I'll just drag the document as it is right now over here. You can see it says we have to write one or two lines of code and explain it. I'm not going to write it. Instead, I'm going to do this screencast, which I think is just a bit nicer. And first of all, I'd like to point out that I think one or two lines of code is incredibly unambitious and just that's just really too little to be able to derive anything from. So I'll start out by just going over one or two lines of code, and then for the rest of the video, I'll actually just go over the rest, show you how our code is structured overall, and because one or two lines of code, that's just not gonna happen. That's nothing. We can actually, if we see here, this is the code in my terminal over here. The code directory. We do a slug count, a source lines of code. For this directory, you can see we actually have 1,612 lines of code. Even that's not a lot, but it's certainly more than 2 lines of code. You can see that the main portion of our code is written in C, and some in Python, and some in Shell, Unix Shell language. Anyway, if I just find my editor really quickly, I lost my editor. Please come back to me, editor. We can have a look up here in the Guardraw. The Guardraw is the code that runs on the Arduino. And if I had to pick one or two lines of code, it would probably be this one, these two. While we have data available on the serial-free interface, we would like to read 1 byte from the serial-free interface and store it in an integer, and that integer has the symbol C. And that was 2 lines of code. So if you're not interested in the rest of the code, but just the 2 lines of code required, I think you're free to go now. But well, if you want more, please stick around, and I'll go over the rest. Well, not all of it, because 1,600 lines of code, even though it's not a lot, takes quite a while to review. But I'll just basically show you the overall structure and what the code is capable of at this time, so you can get a gist of how our code works. In order to better explain this, I think I should pull out my file explorer here. I could also do this through the terminal, but for those unfamiliar with the wonders of the Linux terminal, I'll just do it here graphically. At this point in time, you can see our code directory is quite messy. The reason for this is that a few days ago we had a rocket launch in northern Norway at the Andøya space station, and I haven't really had a chance to clean up these log files. That one's empty, bad example. Oh my god, that's not even a log file. Why are all these empty? I think I might already have sorted some of them. This is a raw output from the CanSat. You can see actually here's a bit of noise even, but I haven't had a chance to clean up yet. We just got back yesterday, some time in the night, so used most of yesterday to sleep, and actually most of today to sleep as well. But enough about my personal life. The code is structured in 3 main parts. The gatherer, which is this code that resides in here. That's just one C file, the file I showed you just before, which is the code that runs on the Arduino. it basically collects data from the sensors and transmits it using a radio module connected to serial 2, I believe, maybe, or serial 3. I don't know. It's not serial 3 because that's a GPS. It's serial 1. The radio module is connected to serial 1. Yeah. The listener is another part of our code, in charge of reading from another radio module connected to the ground station. The ground station is just my laptop running Linux with a quite basic setup. Nothing too fancy. GNOME, Ubuntu, nothing of the ordinary. Yeah, it's in charge of reading from the radio module using this program right here. Basically, this is a terminal that allows us to send data to the CanSat and receive it, and well, it's a modified version of some open source serial terminal, quite heavily modified, in fact. And we don't just write out to the standard out. We actually also write to our log files and our communication files. The communication files really should be a FIFO, but it isn't, because it works without a FIFO, so I don't really want to mess with it. Anyway, this is in charge of reading from the radio module, and we have the listener, which is in charge of taking the raw data, and you can see here, takes the raw data, and it validates the line, sees if it's corrupt, if we have some noise, as we did in the log file I showed you just before. It will skip that line. It will also skip lines sent out by other CanSats because they won't have the right identifier. See the identifier. This is the code in charge of passing the line. Here we see it's not a valid line if it doesn't fit this regular expression. Yeah. But basically, it reads the line, processes it, interprets it, converts it to values that we can use, and sends it out via a WebSocket that any clients connected to our website, which is, I'll explain more about that later, but any clients connected to our website, they connect to this WebSocket and get live data via this listener, which is one of our main features, I would say, is the fact that we can deliver data live to any clients connected, including bystanders or spectators. They can just log on to a hotspot and a website using their mobile phones, and they will be able to see live data during the flight of the CanSat, which is real neat. Yeah. The presenter is just, yeah, I should say the listener is actually coded in Python primarily, which, yeah, you should already have noticed, but in case you didn't, the presenter is also coded in Python using the Flask web development framework. It's quite simple. It's just some Ginger templates, some Ginger 2 templates, and yeah, a rather static site. Basically, it's some HTML. This is actually a static site. The site I wanted to show you is this. This is the live graph site. In a second, I'll just start up the website and show you how it works. But it's just some JavaScript that reads from the WebSocket defined here, and oh yeah, this is me being angry at myself. It reads from the site and renders it onto some high charts graphs. Yeah, pretty simple. I'll just start the web server. 1 second. Have a look here. Start web server. This is just a basic shell script. This must be run as root because it's the port 80, the standard HTTP port. So we have to run it as, oh my god, as a super user. And if we just log onto this site here on localhost via my browser, we can see this is the main site. This is where, if we had a CanSat turned on right now, which we don't, unfortunately, the data would be shown live here, which is really neat. We have also some static data from our drop test that we did up in Norway. See here, it's actually quite funny because the guy in charge of throwing the CanSat from the 50-meter tower was standing up there with the CanSats in his bag, our CanSat and the CanSat from the other team, so it was a competition. And here, at this point, he opens his bag. We're able to see this from the ground, but at the same time we can see live data that the temperature drops when he opens his bag and he throws out a CanSat, and he closes his bag. The CanSat he throws out is not ours. The temperature rises, he throws out another CanSat, and the temperature rises, he opens his bag and he throws out our CanSat here. It's just 50 meters, so it's really not a lot of data, even though we have a refresh rate of, I believe it's about 8 hertz at the moment. I think we will work on getting that up to 10, maybe even 20 if we are able to. Here's the pressure. It's kind of jitterish because our pressure sensor is really bad. We've already bought a new one, a digital one. We just hadn't had it installed during the launch in Norway. But we can see here the data, or from the data, that the temperature drops as he climbs up the tower. And when he drops the CanSat, it falls to the ground and the pressure rises again, ever so slightly. And we're able to calculate the height from the pressure and the temperature at the ground, and here. So we can see when he throws it, it's at almost exactly 50 meters, and he throws it out, it falls down, and it ends up at about 0 meters, which makes sense. We can see here the rotational speed when he threw it out. If we actually zoom in, this is where he throws it. We can see here he picks it up, and here he throws it, and it starts rotating like a madman. And it lays on the ground completely still, and then we pick it up here. Anyway, this is from the rocket launch that we did. We got up to an altitude of about 900 meters or so. We can see some basic data here. I'm not really gonna go over that with you. You can, this will eventually be hosted on the Silkeborg Gymnasium's website, the school I attend, and the school that our team is affiliated with. Anyway, I don't know if I really have much more to show you. Some basic Python code, nothing too fancy. We use the Tornado web or networking framework for the listener. Not really a big deal. This code should run on any Linux machine. Where it gets a bit iffy is the wireless hotspot, which is more configuration dependent. Python basically runs on anything. You'll be able to get most of the code to run on the Windows without major trouble, although I haven't tested that and I have no intention to. I think that's it. How long have I been rambling for? Almost 15 minutes. I guess I'd just like to say goodbye. I hope you enjoyed hearing me ramble and going over little bits of code. actually, to round it off, I'd actually like to prove that I can, in fact, understand Python. So maybe I will just go over a little bit of code with you. Maybe this, I'm not used to using the graphical interface, so whenever I open a Python file, I have to do that until I configure it. Here we basically, maybe I'll take this as an example. This is a class, basically a recipe for how to construct an object. Python is an object-oriented programming language. So yeah, we inherit from the WebSocket handler. Check origin. We don't really want to check origin. Any client that connects to our WebSocket is a welcome client. We log that a client has connected. We append it to this list up here of clients. We write the cache. Basically, that's some data points that we have cached. We write that to the client. Blah 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 blah. Oops. This code is somewhat redundant because we shouldn't ever get any messages from our clients, because the client code isn't coded to delivering messages, so we actually just put a warning if we get a message, because that means a third-party client, one that isn't coded for this, is connecting. So, yeah. Anyway, end of my monologue. Saving. Bye bye.